Hi guys, in the next 3 lessons we're going to be looking at some non-right angled triangles and different forms of trigonometry you can use with them. Before we get on to those techniques though, it's important that we understand how we name these non-right angled triangles. So as you can see from this picture, each angle is denoted using a capital letter and each side is denoted using a lowercase letter. Every side, as you may see, is opposite, the same letter is opposite the angle. Okay, so what we're going to refer to as these being matching or corresponding sides to angles when we start doing these questions. Something else interesting that you may want to consider is the shortest side is always opposite the smallest angle size, and the largest side length is always opposite the largest angle. That level of thought may help you with some particular questions you may be trying to do. Okay, and the focus for today's lesson is using the sine rule. And we're going to be using it to find unknown sides and angles in these non-right angled triangles. Now on your formula sheets, you'll get it written as so. Now it is the same idea or the same formula, it's just where in this top one, you're looking to express your formula so you can find sides. And the bottom one, it's the same formula, but it's been flipped on its head, it's been reversed. And this is the way you'll be writing it down if you would like to try and find an angle. Now what the formula basically says is that the ratio between side lengths is proportional to the angle sizes and vice versa. Now the formula kind of looks a bit funny with 2 sets of equal signs in there, but we won't be using all those parts, all 3 parts, to solve one particular problem. What you are going to need to know if you are finding sides, you are going to have to know a side length and its angle, right? Its corresponding angle, the one opposite it. And you're going to have to know another angle, and that will allow you to go and find that unknown side length that matches that angle. So if we have a particular non-right angled triangle, and we know this angle in here was 30 degrees, and we knew this side length over here was 6 centimetres. What this rule will let us do is it will let us find this side length over here, provided that we know its corresponding angle in that non-right angled triangle. So when I'm considering if I can use the sine rule or not to find a side length, I'm asking myself, do I have an angle and its corresponding side length, the side length opposite that angle? And do I have another angle? And do I need to find the other side length opposite or corresponding to it? If that's the case, I can go ahead and use sine rule. Now, if we were interested in finding angles, same type of thing applies. We must know an angle and its matching side length. Then we must know another side length, and that will enable us to find its corresponding angle. So if I knew that this was 30 degrees, this angle here, and its matching side length was 6 centimetres, and I knew that this side here was 10 centimetres, that means I could use this sine rule to find this unknown angle. So again, we had one full set, a side and an angle that we must know. Then we knew another side, which means I could use this inverted sine rule with the sine of the angle on top to find its corresponding or matching side. Now when trying to do these problems or seeing if you can use sine rule to help you solve problems, you're going to have to rely on some of your stage 4 and 5 geometry skills to sometimes help you out and give you enough information that you need. So for my first picture, the top one, where I was trying to find a side, if I was in fact asked to find this bottom length, but I didn't know this angle here, I could use angle sum of a triangle to find out this angle size. All right, being 80 degrees for these two, So this top part must be 100. And the same with my bottom one, if I'm trying to find a different angle where I don't have the matching side length, I could go and apply sine rule to find this unknown, and then use my angle sum of a triangle to find the answer that I'm actually looking for, right? It would be 180 minus 30 minus theta that we'd go and find. All right, so there are some other little tricks that you're going to have to learn along the way too, because every question won't be straightforward and so obvious, and you may have to think outside the square a bit to be able to go and use this rule. Okay, so let's go and look at example A. It says find the value of x. So we are looking to find a side length. All right, so side length means we're going to be using this version of your formula. All right, so before we begin, let's just check that we can do this. We have a side length given to us. And yes, we have its friend, its opposite angle. And now we have a side length that we're going to want to find, and we know its opposite angle too. Okay, so if we look at our sine rule, we have all the ingredients we need to be able to do a problem. We don't need that third part. All right, it's just saying there is a relationship between all three sides and angles. All right, first step should always be to write down your information as an equation. So my blues I'm going to do first, and I want to find the x, so I'm going to write it on top of my fraction. All right, and I've got sine and then my angle, 43 degrees, 21 minutes. Now this is equal to my other one. Now I'm going to my yellows. Again, I wrote the side on top, so I've got to keep it constant, 10.7 over sine 79 degrees, 12 minutes. Okay, so if you can do that, you're now up to the stage where you just need to solve the equation. Now remember, we want to find that length, we want to find the value of x. So I'm asking myself, what am I going to need to do to this left-hand side of the equation to isolate x? I'm going to multiply by that value, sine 43 degrees, 21 minutes. And to be fair, or to balance, I'm going to do the same thing to the other side. All right, so we are really just going to solve an equation now. Okay, so I've cancelled, right? So I'm left with just x on the left-hand side. So on the right-hand side, what I've got left is 10.7 times sine 43 degrees, 21 minutes, all over sine 79 degrees and 12 minutes. Now at this stage, we can go and enter that into our calculator and find out the length of that unknown side. Okay, so we get a value of 7.4774 and ongoing. We want our answer to 1 decimal place, so we're going to go 7.5 centimetres. Okay, question B, and it says find the value of y. And I'm just rounding it to the nearest whole number. Now y is a side length, so we're going to have to use the version with the lowercase letters on top. Now let's just go and make sure we understand the formatting of writing this answer. Okay, so we have a known side length of 8, and we have its friend, 53 degrees. So we have a match or a set of corresponding sides and angles. The question says, find the value of y. Now the problem is, y, its corresponding angle, is up there in that top corner. We know z. So this is where we're going to have to use some geometry skills. All right, so using angle sum for triangle, angle y is going to be 180, take 24, take 53, which is 103 degrees. All right, so now we have our side length we need to find and its corresponding angle. Now I always start with the thing that I want to find and put it on top. And its corresponding angle, if a y is 103, my other side length that I know also goes on top. We keep it the same. And sine 53 goes on the bottom. multiplying both sides by sine of 103 and putting this in our calculator, we get an answer of 9.76 or 10 units to the nearest whole number. Okay, example C is asking us to find the value of theta in degrees and minutes. Okay, so if we're finding an angle, we're putting our sine of the angle on top this time. So we're flipping the formula over. Okay, so let's look at the information in the triangle. We have a side length and we have its corresponding or matching angle. And we have our angle we want to find and its matching or corresponding side length. So we have all information we need to go and apply the sine rule. Okay, just like before, I'm writing the thing I want to find first and I'm doing it on top, and that is sine theta over its corresponding side length, 6.7. Just like before, sine 86 degrees, 11 minutes on top over side length 8.3. Okay, we do want to isolate sine theta in the next line of working, so we are going to have to multiply both sides by 6.7. Alright, so this will lead us with 6.7 lots of sine 86 degrees 11 minutes over 8.3. Now, just like when you did your right angle trig in the last few lessons, if we want to find just that angle of theta, we're going to have to use our inverse or shift sign. Now, it doesn't change for non-right angle trigonometry either. It's the same for everything. You've got to press shift when you want to find an angle. Okay, so you can go and enter that as such into your calculator, and the answer you'd get would be 53.65 degrees. All right, now it's an ongoing decimal. Do not clear your calculator just yet, because our question said degrees and minutes it wants it rounded to. So you're going to have to press that bubble button, which looks something like that, and it means you've got your degrees, your minutes, and your seconds. Okay, and so when I hit that, it tells me my answer is 53 degrees and 39 minutes. Now there was 9 seconds there, but because we want to round to the nearest minute, it's like time, 30 seconds is the halfway point, so we don't need that last 9 seconds. Okay, I hope you enjoyed that lesson. You can now go and attempt your first set of homework questions. And don't forget to post questions for your teachers on Google Classroom.